and is not yet ready for frontline service. The WS-15 engine represents a transformative leap in China's fighter jet capabilities, particularly for the Chengdu J-20 stealth fighter program. As one of the most ambitious aerospace development projects ever undertaken by China, the WS-15 has been designed to bridge the gap between Chinese and Western propulsion technologies, potentially elevating the J-20 to a peer competitor with the United States Air Force's fifth-generation platforms, like the F-22 and F-35. At its core, the WS-15 is a high-thrust, afterburning turbofan engine reportedly capable of generating 18 to 20 tons of thrust. This places it on par with or potentially exceeding the performance of the Pratt & Whitney F-119 engines that power the F-22 Raptor. This level of power is critical for enabling the J-20 to achieve supercruise, the ability to sustain supersonic speeds without relying on afterburners. Supercruise not only improves fuel efficiency, extending operational range, but also significantly reduces the aircraft's infrared signature, making it harder to track and engage in combat scenarios. The WS-15 is also critical for improving the maneuverability of the J-20, particularly in high-altitude and high-speed engagements. Previous versions of the J-20 were powered by Russian-supplied AL-31F engines, or China's WS-10C, which lacked the thrust-to-weight ratio and efficiency needed to fully exploit the airframe's stealth and aerodynamic design. The integration of the WS-15 would address these shortcomings, potentially enabling the J-20 to perform more aggressive maneuvers in dogfights and evade enemy missile systems with greater ease. However, developing and integrating such an advanced engine comes with significant challenges. High-thrust engines like the WS-15 operate under extreme temperatures and stress, requiring cutting-edge materials and manufacturing techniques to ensure reliability and longevity. Reports of testing setbacks and delays suggest that China is still refining the engine's design to meet operational standards. Even so, the latest video evidence of a twin-seat J-20S powered by a WS-15 prototype hints that these hurdles are being steadily overcome. The road to developing the WS-15 engine has been anything but smooth, reflecting the enormous technical challenges of creating a world-class high-thrust turbofan. For over a decade, the program has been plagued by a series of setbacks and testing failures, highlighting both the complexity of the project and the limits of China's aerospace industrial base during its earlier phases. Early in the program, the WS-15 struggled with fundamental issues related to thermal management and material durability. The engine's turbines, operating at extreme temperatures exceeding 1800 degrees Celsius, suffered from reliability problems during extended test cycles. These failures pointed to gaps in China's ability to produce advanced single-crystal turbine blades, a critical technology for achieving the heat tolerance and efficiency required for modern jet engines. Reports from the mid-2010s indicated that engines frequently failed during high-thrust tests, with some prototypes experiencing catastrophic damage under maximum afterburner conditions. The WS-15 also faced significant delays related to its overall performance targets. Initially envisioned as a thrust leader in its class, early prototypes reportedly fell short of generating the 18 to 20 tons of thrust necessary for enabling the J-20 to supercruise. This shortfall forced China to rely on interim solutions, including the use of Russian AL-31F engines and the domestic WS-10C, both of which lacked the power and efficiency of the WS-15. This compromise limited the operational capabilities of early J-20S, particularly in high-speed and high-altitude combat scenarios where engine performance is critical. Another major challenge has been ensuring engine reliability over a full life cycle. Unlike the short-term test cycles of prototypes, operational engines must demonstrate consistent performance over thousands of flight hours. The WS-15 program reportedly faced difficulties in achieving this standard, with engines showing premature wear and tear during endurance tests. These issues raised concerns about the readiness of the WS-15 for frontline deployment, forcing further design iterations and delaying its introduction. Compounding these technical hurdles has been the broader issue of scaling advanced manufacturing processes. The WS-15's development exposed weaknesses in China's aerospace supply chain, particularly in the production of high-temperature alloys and precision machining capabilities. Achieving consistent quality in such a sophisticated product has required significant investment in new technologies and workforce expertise, further extending the timeline. For the future of Chinese air power as a whole. For China's military planners, the WS-15 is not just another component in the J-20 program. It is a linchpin in their quest for parity, if not superiority, in modern air combat. If fully realized, this engine could dramatically alter the strategic balance in the Indo-Pacific, providing China with a stealth fighter that is not only operationally competitive, but capable of posing a significant challenge to the dominance of Western air forces. If you're passionate about defense technology and want the latest updates on military advancements, this is a must-watch. Don't forget to like, share, and subscribe to our channel for more in-depth analysis.